Hi, my name is Ethan Hunsler, and I am a sophomore studying biology and neuroscience. I want to be a chemistry ULA so I can help other students do well in a class that can definitely be challenging. And a study strategy I would give to them is to become very familiar with the types of questions they can expect to be on the exam just by doing ULA practice problems and lots of practice exams so that when they get to the exam, there'll be several questions that they're not surprised by and they know how to solve quickly and efficiently, and they can be confident that they got right. And yeah, here's a practice problem.
10 milliliters of a 0.25 molar acid solution is titrated with 0.50 NaOH. The Ka of the acid is 4.0 times 10 to the negative 6. Find the pH of the solution at the equivalence point. And I went ahead and already calculated some values just for brevity's sake. First, we're going to write out the equation of the titration, which is our HA, the acid. It's titrated with OH minus to produce the conjugate base and water. We can set up an ice table with this, but first we need to find the moles of acid we have. We can do that by just taking the initial concentration times the initial volume, and that will give us 2.5 millimoles or 0.0025 moles. It's just written as millimoles for brevity's sake and just because it's easier to look at. We can put this value into our initial line of the ice table. We can also put that for our OH because we know at the equivalence point that all HA has been converted to A minus. So we have to have 2.5 millimoles of OH added. For the change line, we just know that these both go away and that it's all turned into A minus. So then in the equilibrium, the final solution, we just have 2.5 millimoles of A minus. And at this equilibrium, the new equation is A minus plus water, and it's producing HA and OH minus, and we can no longer use the Ka that we're given. We actually have to use the Kb since A minus is the conjugate base. I calculated the Kb above, and it's equal to 2.5 times 10 to the negative 9. Now we could use this and we could set up an equation for this to find our concentration of OH minus, since that would allow us to find the pH. We can also simplify the equation to just the concentration of OH minus squared instead of the concentration of OH minus times HA, since we know that these are going to be produced in equal amounts in the equilibrium. So if we're wanting to get OH minus, we need to find A minus, and we know that there's this many moles of A minus in the solution, but we need to divide it by the total volume in the solution. We know we started with 10 milliliters, but we added 5 milliliters to get to the equivalence point. So we need to do 0.0025 moles divided by 50 milliliters, and that will give the concentration of A minus to be 0.167 moles. Substituting our values, we can find that the concentration of OH in the solution, the concentration of OH is 2.0 times 10 to the negative 5. And we can't just take the negative log of this right now because that would give us POH. So we have to do 14 minus the POH, which is 14 plus log of this. And that will give us 9.31, which is the final answer, the pH at the equivalence point.